To solve a trigonometric equation, we use the rules of algebra to isolate the trigonometric function on one side of the equal sign. Then we use our knowledge of the values of the trigonometric functions to solve for the variable. If you don't have a unit circle memorized, I would recommend having one handy, just because when you're solving it, it can make things a little bit easier until you have it fully memorized. So we're going to solve the equations on the interval 0 to 2 pi. That means we want only the answers that are on this specified interval. So for our first equation, we have 2 cosine squared x minus 7 cosine x plus 3 equals 0. So looking at this, kind of looks weird, but it also kind of looks familiar. Kind of looks like a quadratic equation if it was x squared and x instead of cosine squared and cosine. So because I have that, I'm going to do a thing called a u substitution. I'm going to say that u equals cosine x. And so this equation now becomes 2u squared minus 7u plus 3 equals 0. And now I'm going to solve. I'm going to use factoring to solve this. So I'm going to get 2u minus 1 and then u minus 3 equals 0. And then I will solve and I will end up getting u equals a half and u equals 3. Which is all well and good, but in my original I have x's, now I have u's. That doesn't really help me any. So what I'm going to do is I'm going to take what my u's equal and I'm going to use my u substitution to solve for cosine. So when I do that, I'm going to get cosine x equals a half and then cosine x equals 3 and solve. So on the unit circle, where does cosine x equal a half? Well, only 2 spots. Cosine x will equal a half only at pi over 3 and at 5 pi over 3. Quadrants 1 and 4. Now what about cosine x equals 3? Where on the unit circle will cosine x equal 3? Well, if you look at the unit circle, you'll see that this happens nowhere. This is not possible because cosine x cannot be greater than 3. So the only answer we have are pi over 3 and 5 pi over 3. Next, we have the equation 1 plus sine x equals 2 cosine squared x. Now we got sines and cosines in here. Not a good thing, but nothing we can't handle because I remember the Pythagorean identities for cosine squared or sine squared. And I know that cosine squared can be rewritten very simply as 1 minus sine squared x. Don't forget, sine squared plus cosine squared equals 1. I can solve for cosine squared and I can use that fact to replace cosine squared with this. Now I'm going to distribute the 2 inside. 1 plus sine x equals 2 minus 2 sine squared x. And then I can move everything to one side and combine like terms. So I'm going to get 2 sine squared x plus sine x minus 1 equals 0. And this is similar to the one before. I can use a u substitution, say u equals sine x, turn it into a quadratic. So 2u squared plus u minus 1 equals 0. Factor 2u minus 1, u plus 1, and then solve. U equals a half and u equals negative 1. So again, I started off with x's and I ended up with u's, so I need to actually plug these in here to find out what x equals. So I'm going to end up with sine x equals a half and sine x equals negative 1. Now where on the unit circle does sine x equal a positive 1/2? On the unit circle, you would see that it equals a positive half at pi over 6 and 5 pi over 6. Quadrants 1 and 2. Now where does sine x equal negative 1? On the unit circle, you will find that it only equals negative 1 at one spot. On the y-axis, between quadrants 3 and 4, at 3 pi over 2. So the solutions to this trig equation is pi over 6, 5 pi over 6, and 3 pi over 2.